Oh, hello! Well, now it's the time to make the other part for this rotary vane compressor. Well, it will be the other plate on the other side of the pump. Well, it's very similar to the previous one, but this one has a little bit more holes in. Well, let's meet in my little bit warmer workshop. So, see you there. Yeah, okay. Now, well, let's get rid of this gear. This is not exactly the ones you would like to wear when working in the lathe. So, lathe it will be. So now, at the lathe. There are two workpieces we are going to do. Today I will now show them to you. So here you see the entire unit. So let's now take all the components we don't make today away from this, like that. And there is now two components. This is the plate we are going to make and a bearing. The plate is very simple, and then we have this bushing here, which is then press fit at the center of this thing. Yeah, okay. Oh yeah, and now let's just start with the book and make it a level book in the lathe. Okay. Now the dividing head and the milling table are actually aligned from the previous operation, so I don't need to search for the center point of this. It's already there. But what I need to do is to dial in this workpiece into these jaws, and this is exactly what I'm going to do now. I will just put it there, and my first task is to, well, it has to be set up so that it's away from the jaws, so that there is a gap, because otherwise it will, the drill will hit the jaws. Now it's level, but it's rotating like this. So now we need to dial it the other way around. Let's see now how much is it. Okay. Now we are talking. Well, now I'll tighten these a little bit so that they are equally tight, and recheck the wobble. The wobble should stay within, well, this didn't stay within, so that's now high. No more. Good. Oh yeah, and then the wobble. Let's see. It's inside 200ths of a millimeter. It's okay. Wow! It's dialed in. Let's just one more time check that these are all really tight. Yes, they are. Okay, it's dialed in. Well, in this case, the direct indexing of this dividing head cannot be used. This is because we need division to 16. Not only 8, but 16. And therefore I must be using now the indirect indexing here. And the indirect indexing is using the worm, which I now first will engage here. This is easy enough. Let's see that it really is engaged properly. Yeah, it is. If we would be doing like 8 holes here, bolt circle of 8, well, it means that you have to turn this crank here for each revolution 40 times. So 40 divided by 8 is 5. So for each hole 5 full turns. But then we are having like a bolt circle of 8. But then we need to have holes in between those. And this is now, I just turned this 2.5 turns. And then we are right in the between. And then we go on from that point, 5 turns for each. So then we get the holes in between there. So why this? Well, I want to avoid a lot of work here. So I will do the 4 millimeter holes first, then I will do the recesses for those, and after that I will do the additional holes in between those. If I would, I could do it in a way that I first make the 4 millimeter hole, change the tool, and then take the end mill and make the recess, change and then change to the there in between, and then change here the 3.3 millimeter drill and make the hole. And then again, so a lot of tool changing. I don't like that. So therefore we are using this indirect method of indexing. And then, well, it will be like 2.5 turns, so I think this disc can do it. It has 20 holes, it has 18 holes and 16 holes, which are, each of these are paired numbers, so you can see here are the half holes here in the bottom. So I can use this one. So I use this one. I put it there. And well, in this case, I'm not using the sector arms. Yeah, really, they are not really needed in this case because it will be always full turns. So now I turn this until I reach 0 here. So I know always where to start. Well, that's the 0. Okay. Next step, we will drill the holes here now. We have a drill. It's located in a suitable place. And, well, it's just do it. Well, now let's change a smaller drill here. This is 3.3 millimeter drill. I will change this too. Well, so now these holes go right in between those holes. So I need to move this because the distance between those holes is 5 turns. So now it's half of that, which is 2.5 turns. So 1, 2 and half. Now it should be right in between there. Okay. Well, now it's just to drill 8 more holes. Now I will change this drill to, well, 7.75 millimeter end mill. There. These recesses will not be for these holes we just drilled. They will be for the original holes. So I will go to, oh well, let's go now 2.5 turns. I could also go to the original 0. But let's try first 2.5 turns. So 1, 2.5. There. And now let's count 5 turns. 1, 2, 3, 4, 5. And now we should be in the original 0 hole, which we are. And well, next I will touch just by trying to feel this like this. There you are. I don't use any force in there. I zero my dial here. I put this scale here to 10. Okay. Now I just from this point, that point I plug in 4 millimeters and it should be there for those recesses. So let's do them now. Okay, the recesses are now there. So now I will change this end mill to 3.3 millimeter drill, which is then going to be the next. Yep, that's the original 0. Here. And now this hole, that's the oil return hole, and it should be 23 millimeters away from the center. So 23, 10, 20, 21, 22 and 23. There. And now we drill a hole to there. Well, next there will be, an 8 millimeter hole. It will eventually become 24 millimeters, but not in this constellation. So this is 7.9 millimeters. And I will use an 8 millimeter reamer to finalize the size. And this hole, the next hole, will be used to locate this thing on the table when I do the final size. So, okay, and this is a little bit so, well, in the picture, we just made that hole. So, and now we are going to put this one, and it is 1, 2, 3 holes that direction. Oh man. So now I'll just drill that hole. Now we have quite an exact 8 millimeter hole in there. Well, at least I hope so. This is an 8H8 reamer, like that. And it's, well, I hope that I have an 8mm pin that goes into that hole. Let's see. I'll check. Well, this should be quite exactly 8mm, and it should go there into that hole very precisely. Yeah, there is almost no wiggle at all. From this distance, about 1mm. So, yeah, I'm pretty sure it will. I can use that one for locating this. So now what I will do here, I will dismantle everything, and then I will set up my Wohlhaupter thing here. Okay? Okay, let's set this machine up. There you are. Done. 8mm pin, 8mm hole. Okay, I'm using this hole to locate the workpiece here under, like this. The table I have moved and locked it to a place where I can come back later on. In this case, I don't move the table to orient this, I move the workpiece to orient it to the table. So here are two 24mm parallels. Well, it's there, and it most certainly will sit in there. Now we can remove the pin. Like that. And now the workpiece is in place. Well, next we will drill a hole into that one. A large hole. The final size will be 24mm. Well, let's see what kind of drill I can find for that one. It's Wohlhaupter time. Now we have a 22mm hole in there, and it should be 24mm. I attach my Wohlhaupter here. Oh, Let's take the table up a little bit. I don't know how deep it will cut. I will now first take a single pass through and then I will measure it. After that we know. Now I'm going to make 8 M4 threads into those holes. And now, well, first of all, the setup of this workpiece. It's floating sideways, like this, but it's not floating vertically. Okay, and then I'm using my Tapmatic. Well, this is a reversible tapping head. It means that when you pull it back, it will rotate the direction, and it should come out from there. This device has a brake which I have now adjusted to some value. I'm not sure whether this value is correct, but we will see. And then what's nice about this, oh yeah, and I also have set up a quill brake, quill stop. It won't go deeper than this, so I don't go past the threading part. Okay, let's try first and see whether we break this tap or whether this torque is enough to drive the tap and not break it. Okay, let's go. Well, I believe my torque setting is all right. It requires some setup time, and now it tries to the brake engaged. Apparently the brake is in correct value. It stopped because there was too much torque. Oh, okay. Well, I think I will wear a glove. I know it's not very good idea in a drilling machine to wear a glove, but in this case I want to have it because these edges are sharp at the moment. So having a glove, this is absolutely wrong. You shouldn't do this. Never ever do this. Yeah, okay. Maybe I should tighten the brake a little bit. Just a little bit. Like that. Because it didn't want to go all the way through. For some reason. Where to put this canister? Now I hope. Yeah. Yeah. That's okay. Through. Next. This goes really fast. And well, actually it's very hard to break your tap with this if it is correctly set up. Okay. There we go. It's true. Next. Yeah. This is definitely faster than doing this by hand. Or with a... Well, you can use your drill, hand drill. But this will... It's very hard to set up the torque correctly so that you don't break your tap. That went through in one go. Wow. And believe me or not, this is the last. Ha! That was really fast. Now this is very practical unit if you have to do, let's say, a pallet of, which has a lot of similar threads. So this is very good for that kind of things. Yeah. There you are. They are done. Ha! That was really fun. Now the glove away. Yeah. Well, that is really nice unit, Tapmatic. Is a bushing I turned in the lathe. Well, and I noticed that I lost the footage. I have the speech, but well, audio drama is not my intention here. So, the puck is in the oven at the moment 300 degrees. And now I will cool this down using this cold spray. Hopefully I still have something left here. The intention is to cool it down as much as possible. Yep. It's cold. And now I will take the puck out of the oven. Here it is. 300 degrees. It should drop in, but you never know. It almost did. I have to place it so that I can push it down before it heats up. No. I didn't succeed with this one. Oh man. I was too slow with this. It should go, yeah. Let's see. Okay, there we have some tool steel Sleipner, and then I can use a hammer. Huh. There you are. That was not too bad at all. It's a press fit, so to say. Yeah, there you are. Wow. Whew. Well, that didn't go as planned. Well, that bronze piece, bronze bushing, should have just dropped in. Apparently it didn't, but lucky us, it didn't. The shrink, the fit was not too tight to be pushed in. Sometimes if you have that kind of shrink fit, it's too tight. You have to have a temperature difference in order to get this thing working. And yeah, it's really, well, sometimes things are like that. Well, you never know how it is, and yeah, sometimes they just don't. Well, in the next episode of Finno-Ugric Machining, we are going to make yet another book shaped piece, but this time it has a lot of precision recesses. It's the book that contains the oil pump, and this will be really, well, something. Till then, bye!